So I'm Joram, and today, we'll tell you a bit more about how we crack the code at Manychat. So how do we supercharge our product quality and do that every single sprint? Just a little intro about myself. So I'm Joram, I'm working in the IG area with Manychat. I've been working with Manychat for about a year, and originally, I'm from Belgium. But I've been living here for about 3 years in Spain, Barcelona. And during my free time, I like to practice yoga and go mountain biking, but maybe we can talk during the break about this. A little bit of an introduction about Manychat, although Anton already gave a lot of information. So Manychat, we serve about 1 million customers who use our products. And last year we automated about 1 billion conversations. And we're active, our customers use Manychat in about 170 countries. We're the leading chat marketing platform, and our mission is, of course, to help businesses grow by building meaningful relationships with their customers. And that's also, drive sales and conversions on these different messaging apps using our automations. Here we see the different channels. But it's not only, we don't only connect with Meta, we connect with third-party platforms rather a lot. So it might be about payment processing systems, CRM systems, HubSpot, etc. So it's very, very important. It's crucial for us to be able to respond quickly if there are changes. That's why we adopted the LESS framework. So this large-scale Scrum framework that applies best to our situation. And that means that we are working in cross-functional teams. So we have 2-week sprints, and each team consists of about 2 backend devs and 2 front-end engineers who are assisted by a product designer. Before we start, let's take a look at what do we actually mean when we are talking about software quality in general. We, of course, to measure it properly, we don't only need to measure we're building the product the right way, but also that we are building the right product for customers. Because it's not only about technical value, maximizing our development process value, but it's about achieving the goals, the product goals, and supporting our customers and achieving their business goals. What does it consist of? When we talk about a high-quality software product, what would be the characteristics here? First of all, like I said, the focus should be on our customers and what they are trying to achieve. It should meet the business objectives of these customers, but also the product should be intuitive and easy to understand. Nobody of our customers wants to lose time to figure out how a certain feature works. It should be intuitive, so our customers can actually dedicate their time to their business. Nobody wants to, like I said, nobody wants to be boggling around to figure out how something actually operates. And also on a technical level, so we need to make sure it's compatible with high-level or high-load system requirements. So if it's necessary or applicable, we need to be using queues, and we need to make sure that the solution is scalable and reliable. And I think it stands without saying, but it should operate without bugs. For today, I will talk a bit more about our quality approaches. So if I situate this in the software development lifecycle, so it shows the 6 phases until we get to a shippable or a software product that's ready for the market. We will focus on 3 phases, actually. We'll be looking at the planning phase, how we achieve quality. We will look at actual implementation, and then we will also be talking about our approach to testing, team testing, and integration before we finally can ship the product to the market. So maybe let's start with planning. Maybe some of you are familiar with sprint planning, and maybe some of you are also familiar with this phase at the beginning of the sprint planning. At least I have been there quite a few times. But first of all, let's take a look. Why do we plan, actually? Well, planning, it guarantees performance, and everybody is on the same line. So we understand what needs to be built, and everybody is at the same level. But also, in planning, we can still make mistakes, and we can have misunderstandings, because they are very cheap to resolve. If we only clarify these things later on during the implementation process, it will be very expensive, because everybody in the room here probably knows that coding is very time expensive and also costly in general. So first of all, we need to decide in this planning, what will we code? What will we be building? We have two phases there. We refine a backlog item. So in terms of content and scope, we define what needs to happen. We go to the sprint planning one, and then we kind of decide what is the capacity to take this into the teams. And then, yeah, after all this has been done, we also need to decide how will we actually code it. So how does it break down into technical parts, and how do you distribute it inside the team? And that will be our sprint planning 2. So let's take a look first at the backlog refinement in general. How does this work? So yeah, we have a product owner, and he will be presenting an ID or a problem to our teams. And we will not actually be discussing code there, but it's more about the problem proposition and the overall design possibilities to solve this. So we'll be looking at functionality risks and, of course, yes, supporting our customers' business goals. And then, yeah, we'll have a kind of a discussion between the different competencies, so design, front-end, and back-end, and they will all give their perspectives. And it will also determine, it will determine the estimate, because it's based on the complexity, and these different competencies, they all have their own perspective on the complexity on their side. So the more competencies that are involved, of course, the complexity goes up, and the item will be estimated as larger. And it might also be that we have people in the company, they worked previously in parts of the product, or they have expertise in this certain area or this functional area. We will call them into the refinement session to join us into the discussion. So we can actually gather the maximum information, the maximum knowledge possible that's present in the company about this issue. And then, of course, the most critical part will be to define actually what is the requirements that we're trying to address. So it's defining these acceptance criteria. And so it's about making it ready in terms of content and understanding for everybody. And then if we look at the acceptance criteria, what does it consist of? We have both functional and technical ones. The functional ones, why are they very important? Well, we need to describe in user language what will they see change in the product. It's also very important if we want to later test that we can use these acceptance criteria to actually have a checklist to validate against. And then also, on a technical level, maybe you want to use some database tables, maybe you want to build something on top of existing components. It should be written down in the backlog refinement. And then last but not least, we have a clear design link that shows how this looks like in the product. And then we come to our first contract that we adhere to in the company, and that's our definition of ready. So once an item, so a task has gone through this process, it's deemed as ready, and we can actually send it to the teams to start working with it. This is an example of a task that has gone through backlog refinement. So first we see the motivation where kind of like the PO, he will give an introduction about what is the goal. So here it was about broadcasting creation, and it was not entirely clear for the end user how to reach this part in the product. So it is explained that this is the goal of this task. And then we also have a list of all the functional criteria that need to be implemented by the developers. So we have the design link, the Figma file, and then we have an estimate that was made based on the complexity between the competencies. We are using t-shirt sizes, so this one was estimated small, but might be medium or large. So after this, after we have this backlog refinement, we can actually take it to sprint planning 1. And in sprint planning 1, the teams will decide what they can take into scope, the next sprints. And it's all the teams working on the same part of the product. So I'm in the IG area. If my team goes into this planning meeting, the other team that's working on this part of the product will also be there. And then in parallel, we go into breakout rooms, and we discuss what's feasible, what's possible within the team, and we come back for transparency into the main room, and we share with the other representatives of the teams what we're going to do. After this, we can independently, the teams can have coordination between their members. So they will do the actual composition of the tasks, so the destructuring, defining sequence of actions, and also see how we're going to implement it technically. So it's going to be a more technical, detailed discussion. And also see if there are any blocking issues, maybe in terms of planning within the team and capacity-wise. So after that, we deconstructed our task in the planning. We can actually start building it. We can start implementing, the interesting part. And here we also have a contract. We cannot just build anything. It needs to adhere to our quality standards. And for us, it's the definition of done. And it applies to any task. It doesn't matter what the size is. It doesn't matter what the impact is on the product. Everybody understands what the outcome is, and yeah, it also like sets the criteria for knowing when a developer considers it finished. No, he needs to go back to the definition of done and see if he checks all the boxes. And every team follows the same checklist. So yeah, it's going to guarantee that we use optimal resources, and the code is intuitive and stable. And let's take a look at the actual checklist. So yeah, the code is written with our established requirements. So we're talking about code style. We're talking about certain performance considerations, but it might also be about reusing certain approaches that are already present in the code base instead of reinventing the wheel. Of course, yeah, we have a code review that has been passed, and if there is discussion in the team, it might be best to jump on a call so we can solve it synchronously and as fast as possible if there is a large discussion there. The design has been reviewed, and of course, yeah, we also have automated integration and unit tests that are present. And finally, we can release this into production, but yeah, we cannot just release it like that into production and let it run free. we need to make sure that we test it in production. And then, yeah, a critical part, it's actually also kind of a contract. This is the contract, it's not with the developers, but it's more for our support teams. So we fill the internal changelog with all the features and bugs that we fix or release into production. Why is that? Well, if there is some kind of incident or some kind of big problem at the support side, they also need to know what happened recently. So they can go back to the changelog and they find out who they need to chase to solve this issue. And then I come to the part about team testing. So yeah, we don't actually look like this guy. I liked it. The team tests, we don't really have any dedicated QA engineers. So every team, they need to test their own stuff. They need to test their own implementations. The good part of this is that it gives an opportunity for everybody to be in scope. Everybody knows what's being built in the team. There are no blind spots. And mostly it will be one backend and one frontend engineer. So the people who actually build it, they will be refining or writing the test. But possibly there might also be other people who are interested in this team test. It might be that the PO joins to check if all the ACs have been implemented correctly. Or maybe the analytics competence wants to check if their data has been integrated correctly into the end solution. So yeah, everybody's involved, and also it allows us to go seamlessly. It streamlines the delivery of value to the users, and we can just plan testing and deployment independently of each other. So the checklist, the actual team test. So yeah, this is a document which has all the testing conditions. So it's the actual behavior in the product, the actions that the user can take in the product, and then what we expect to see or what we expect to not see, because there might also be adverse effects in other parts of the product. And we will specify this in writing. So yeah, like I said, it's going to be the persons who worked on this who's going to prepare this. And yeah, we do the classic approach where we first test in dev, we go to staging, and finally to production. So team tests in production, well, how do we do that? We cannot just roll out. We might disrupt our users if we just release untested features. So we release them under feature flags. And we actually test the features only with our internal accounts. So this code path, for most of our users, it will not be activated. So if there's still bugs present, it will actually not be affecting our users in production. And after we have done the checks in the production environment based on this checklist, we can do some bug fixing. And after critical bugs have been fixed, we can open it to either a group of users or the entire user base. Yeah, and this is an example of how it may go. Yeah, if we discover bugs, like I said, we fix them. But it might also be that we stumble upon bugs that are actually not related to our increment. So then we will make a judgment with the product owner to see if we can prioritize them within the backlog and where they belong in the planning. So yeah, this is once again just a summarization of the different phases. If we go into release, into production, so we have the checklist, we have the team test that's prepared before we go to production. We actually put the feature into production under this feature flag. We check all the requirements in this document together with the team. And then we make a list of all the bugs that we find. We do the bug fixing for the critical bugs. And after the bug fixing, we can actually open it to our user base. This is an example of a team test that we did for WhatsApp for storing locations. So we have two parts of the product here that we tested. We have our basic flow builder and our flow builder. And it kind of lists, so okay, this is the action, user interacts with a button, and he sees this expected outcome is he sees the replies from the contact. And then, yeah, we make this extensive list of bugs. Here, none were encountered. It was a very good implementation in the WhatsApp area. Congratulations. But there's also sometimes more extensive bug lists. So this is an example of the icebreakers features that we implemented, and it was less successful. So here we can see that the bugs are categorized. They might be improvements, or there might actually be bugs that are blocking. So they need to be fixed before going to production. So yeah, one that was blocking here was related, the last one was related to translations. And then, yeah, another part, it might be that we have sprints that take more than one sprint. So they are so large, so complex that they require more than these 2 weeks. So yeah, we're going to have multiple teams that collaborate then on the testing. Yeah, and it's even more important in this case to test thoroughly. So invite as many people as possible, do epic testing, hold a testing day, and have all the representatives join us and try to break the application. And it's once again going to be the same. We have a prioritized list of bugs, and other non-critical bugs, they're going to go to the backlog to see if we can resolve them later. So how do we guarantee quality? Well, the conclusion is we need to have clear contracts in each phase. So in the planning phase, we have the definition of ready. So we make sure there's a clear understanding of the task. And then we can actually start working on it, after which the developer checks the result in the definition of done, does it comply with it, and also executed successful team tests in production. And these are the 3 ingredients for high-quality software product. And this brings me to the end of my presentations. Are there any questions? Thank you.